Good morning students, this is Junita Mukherjee once again in SS Public School giving you a new chapter notes about this oscillations. This chapter is about oscillations and we know what is oscillation. From the 11th standard practical we have oscillations of the pendulum which we have already done. This chapter is connected with that of it and is it a simple harmonic motion of the oscillations of the pendulum? Yes, it is a simple harmonic motion. How it is a simple harmonic motion? I will let you know in this particular chapter. So here we have the introduction first of this particular oscillation. Oscillations means moving of a to and fro motion of a particular substance from one position to a new position and then from the new position again to the one position to the previous position is taken as one oscillation. Okay, or you can, if you move in a perfect diameter of a particular room itself, so when you are moving from one particular starting point to the final point itself and again final point to the starting point itself is considered to be as one oscillation itself. So in our daily life we came across various kinds of motion. We have learned about the some of them like linear motion, motion of a projectile. Both these motions are non-repetitive. We also learn about the uniform circular motion and the orbital motion of the planets in the solar system. In this case, the motion is repeated after a certain interval of time. It is periodic. In our childhood, you must have enjoyed rocking in a cradle or swinging on a swing. Both these motions are repetitively in nature when but different from the periodic motion of a planet. Here, the object moves to and fro about a mean position. Examples of such periodic to and fro motion of, about a boat tossing up and a drone in a river and motion about a boat tossing up and down in a river and the piston in a steam engine going back and forth etc. Such a motion is termed as oscillatory motion. In this chapter, we study this motion. The study of oscillatory motion is basic to physics. Its concepts are required for the understanding of many physical phenomena in musical instruments like the sitar, guitar and violin. We come across vibration strings that produce pleasing sounds, the membranes in drum and diaphragm in telephone and speaker system vibrate to and fro about their mean position. The vibration of air molecules make the propagation of sound possible. In a solid, the atom vibrates about its equilibrium position. The average energy of vibrating being proportional to temperature, AC power supply gives voltage that oscillates alternately going positive and negative about the mean value 0. The description of a periodic motion in general and in oscillatory motion is particular required some fundamental concept like period, uh, frequency, displacement, amplitude and phase. These concepts are developed in the next section, periodic and oscillatory motion. For example, this some periodic motions are considered to be as the motion of the repeat itself after regular interval of time is what we call the periodic motion here. So periodic and oscillatory motion are given in this particular manner. Here is some considered, we have considered this periodic motion, that is a certain motion which is repeating after a certain interval of time. That is, we have taken the first graph. In this particular zigzag motion of this particular graph at a certain interval of time it has been done. So this particular area is taken as t and here the motion is towards the t and xt here. All these graphs are like that only and it has been repeated after a certain interval of time. This particular motion is being repeated. So this periodic motion, that is periodic t, is shown in each case here. T is here shown, it is the t here, it is the t here, that is t, the periodic motion itself, the periodic t, periodic motion. Or h is equals to ut plus half gt square for downward motion and h is equals to ut minus half gt square for the upward motion. So upward is gt square and downward is this one, that is ut plus half gt square itself. So upward motion is something like this, okay, and like this upward motion, this and this, and downward is this one, okay, this one is a downward motion. So this particular oscillatory and periodic motion has some things to explain, that is shown in the figure which has been shown in the blackboard as the periodic motion. Suppose an insect climbed up a ramp and falls down. It comes back to the initial position and repeats the process indicated identically. If you draw a graph of the process, graph of its height above the ground versus time, it would look something like, if a child climbs up the steps, comes down and repeat the process identically. Its height above the ground would look like figure B when you play the game of bouncing a ball of the ground between the palm and the ground. Their height versus time graph would look like the figure number C itself, that is which is at the lights itself, the bouncing ball of a substance. Bouncing ball. This ball has been taken in the hand. This is a ball here, okay, and this is A, B, and C. Okay, so this thing, ball in the ground. This is C, A, B, and C. We have already been here mentioned here. So this particular graph is being shown here, that is when you play the game of bouncing a ball of the ground between your palm and the ground, this height versus the time graph which will look like figure number C, and note both the curves of 4 points, figure number C and section of the parabola given by the Newton's equation of motion, that is h is equals to ut plus half gt square in the downward and in the upward by minus ut plus minus half gt square in the different value of u in each case. These examples are of periodic motion, and thus a motion that repeats itself after a regular interval of time is what we call the periodic motion. Even often the body undergoes periodic motion, has an equilibrium position somewhere inside its path. When the body is at the position not net external force or acts on it, therefore it is left there at rest. It remains there forever. If the body is given a small displacement from the position, a force comes into play where tries to bring the body back to the equilibrium position given by the oscillatory and the vibratory motion. For example, a ball placed in a ball will be of equilibrium at the bottom. It is placed a little from the point, it will perform oscillations in the bowl. Every oscillation in periodic, but every periodic motion need not to be oscillatory. So a circular motion in a periodic motion, but it is not oscillatory. There is no significant difference between the oscillatory and vibration. It seems that when the frequency is small, we call it oscillatory, like oscillations of the branch of tree, and while the frequency is high, we call it vibrations, like vibration of a string and of a musical instrument. Simple harmonic motion is the simplest form of the oscillatory motion. This motion always arises when the force of the oscillating body is directly proportional to the displacement from the mean position, which is also called the equilibrium position, and thus further at any point in the oscillation this force is directed towards the mean position. In practice, oscillatory bodies eventually comes to rest at the equilibrium position because of the damping due to the friction and other dissipative causes, and however they can be forced to remain oscillatory by means of some external periodic agency. Thus the phenomena of damped and forced oscillation later on this chapter. Now at any material medium can be pictured as a collection of a large number of coupled oscillation. The collective oscillation of the constituents of the medium of the manifest themselves as waves. Examples of waves including water waves, seismic wave, electromagnetic waves. We shall study about the phenomena in this next chapter itself. So this particular oscillatory or oscillations of the simple pendulum is considered to be as a simple harmonic motion, and thus it has been told here that simple harmonic motion is the simplest form of oscillatory motion itself, and thus the motion arises from the motion of the oscillating body is directly proportional to its displacement from the mean position itself, and further at any oscillation this force is directly towards the mean position. So it has been told that all the simple harmonic motion is in the form of the oscillatory motion itself, and thus it can be a vibrational motion itself, that is vibrating just because of the frequency of this way of this oscillatory motion of the pendulum, or any case when the object is in oscillation, and thus we will get the vibrations in that particular object itself. So which is also already given in this particular chapter. Some examples, that is motion of a pendulum, simple pendulum, it vibrates also and oscillates also. In comparison to that, it vibrates, why it is vibrating, it is vibrating towards its mean position itself, and thus this oscillation is being taken place. Vibration means a kind of a form of a wave moving through this particular bob itself. That is what we call the vibrations. As we have already discussed here about this oscillation and the vibrations of this particular pendulum here, and thus the practice of the vibrations will be properly given by damped oscillation and forced oscillation, by how the vibrations are being taken into oscillation, or the oscillations are also only called the vibrations itself. Okay, because there is some or more, some or the other vibrations will be there in the periodic motion, in the oscillations of the simple pendulum. So this particular topic is being over, and I think I have made you understand what is periodic, what is oscillatory motion. It is just because of the oscillations of the pendulum, which is moving to back and forth in this particular experiment. So looking forward to the next session, to the next video, in which I will explain period and frequency, and we will discuss about the displacement of the simple pendulum in detail. Thank you, students.